The definition of logarithm. The definition of a logarithm is the power to which a number must be raised to get another number. The definition of a logarithm is the exponent that is missing there. That's what the definition of a logarithm is. A logarithm is equal to an exponent. You got to remember that the logarithm is equal to an exponent. So when we say something like 2 to the x equals 16, I bet you know the answer. It is a 4, right? This is the same thing as the logarithm, log, of the base. What is my base in 2 to the x equals 16? What's the base? 2. So log with a base of 2, so we put that little subscript 2. 16 equals x. And you guys just told me, well, that is the same thing as 4. So log base 2 of 16 is 4. So logarithm is what is that exponent that makes it true. Okay? I want to show you something else. Excuse me. There are like different ways of manipulating these logarithms. So I want to show you another way. You totally knew the answer was 4, but maybe somewhere else you would want to use this thing I'm about to show you. So I know you knew the answer to this. But we could write it, we could rewrite it a different way. You can write logarithm base 2, and then take 16 and write it as a prime number to an exponent. 16 is what to the what? 16 is not 1. 16 is what to the 2 to the 4th. That's how you knew the answer to that. 16 is 2 to the 4th. And when you look at this equation and our final answer is 4, what happens to log base 2 and the base of 2? They are inverses. They undo each other, and we get 4 as the answer. So these are inverses of each other. They undo each other. That's how we are getting 4. But you knew the answer, so it's good. So some of these you really don't have to show much work because you know the answers, but I'm not going to give you anything crazy that you don't know the answers for. It's just practice. So let's go through it again. 3 to the x is 81. I know you know the answer for x. Are you sure? 4. Can we write it as a logarithm? So the log base 3, 81, is equal to the exponent, which you know is 4. Right? And again, showing you that other inverse thing, if I write log base 3, I can rewrite 81 as 3 to the 4th, and then you can see these canceling out and getting 4. That's our answer. So now it's already in logarithm form. It's already in log form. So we can rewrite this in exponential form if it helps us. Or we can do that inverse thing. So I'll show you both ways. So we want to write this in, if we want to write it in exponential form, what will be our base? 4. The base is the base. And then this equals an exponent, but I don't know what the exponent is, so x equals 1/16. So that would be an exponential form. If we had it in exponential form, then we could do what we did last night for our last page of notes for that assignment, where you make the base the same on both sides. Or the x is equal to, can we make 1/16 into a power of 4? It will be negative, that's where the reciprocal happens, and then the squared makes it 16. So then x is negative 2. So if that helps you, you can do what we did last night, and that's why we did that last night. I'll give you options on solving your homework. We could also rewrite it inverse, using the inverse. You could write log base 4, and then you could take this and say 4 to the negative 2, so those cancel and get negative 2. However we do it, the answer is negative 2. Okay. The next one, log base 7 of 1. So this would be 7 to some power equals 1. The only way we can get a number to a power to equal 1 is if it's to the 0. So just remember, any number except 0 to the 0 power equals 1. So this answer is 0. It's undefined. Okay, in this little paragraph, it's talking about how the log base a of x equals y is the same as the exponential equation, a to the y equals x. This is just what we were just talking about with numbers. But it does tell us one more important thing, that if the base is not given in the logarithm, if the base is not given, then we know it's 10. If the base is not given, it is 10. It's called a common logarithm. It's so common that it's on your calculator. There's a log button on your calculator, and there's not a base on it because it's base 10. So here, if we have log of 1/100th, then I know it's base 10. And if you need to write in base 10 to remember that, that's fine to help you with your, manipulating of the equation. Do we know the answer to that? -2 would be the answer. It would be 10 to the what is 1/100. So that answer is -2. Okay, so questions that are similar to what will be on your homework. The first one say just change it into exponential notation. Just change it into exponential notation. So what is my base? So the exponent is 3 equals 343. And then you think, does that make sense? Is 7 to the 3rd? Okay, so we did it right. But please take that extra step to just think about it and to make sure it makes sense. What's my base for B? 10 to the what exponent? 4 equals 10,000. Is that true? Yes. Yeah. And then C, what is my base? 3. To what exponent? Y. The y equals 5. That one you can't really check. You don't know what y is. She good. Solve for y. Okay. Next, we're taking exponential form and putting it into logarithmic form. So all of these will write log. What is my base for A? 6 is the base. Then what it equals comes next. Equal sign, always the exponent is what the log function equals. It always equals the exponent. So the next one is log of what base? Do I write a 10? Don't write the 10. No. Not free finally. If you need it to use it in your work, that's fine. But if it is a log base 10, we don't write it. Okay. And then the last one is log what base? Base 16. What number? 2. Is equal to 1. Okay. If you are working ahead, you can do the next section, but I did change one question in the very bottom section, so don't totally work all the way through because I changed the question. This section, we are just simplifying. So we are finding log base 5 of 125. So remember, logarithms are what is the exponent on the base 5. That equals 125. You're thinking 5 to what is 125? 3. Just yell out any answer. I'm sure it's one of them. Yeah. All right, the next one. What is our base? So we're doing 10 to some exponent is equal to 1. 0. Good. If it equals 1, it's going to be 0. And the next one is 32 to some exponent is equal to 2. All right, let me work through this one. Let's do this like we did last night's last page of notes assignment. 32 is a prime number to an exponent. What is it? 2 to the 5th, and then there's already an x up there. So it's 2 to the 5x. And then this side is 2 to the 1st. So since I have the same base on both sides, what do I do to my exponent? So 1/5 is our final answer for that one. 32 to the 1/5. The 5th root of 32 is 2. So you might not always need it, but sometimes it is helpful to make the bases the same on both sides. How about D? 5 to what exponent is 5? 1. 3 to what exponent is 1/81? -4. F is 2 to what exponent is -4? That one was on yesterday's assignment. We can't take a 2, a positive number, to an exponent and all of a sudden make it into a -4. That's not going to happen. And I have comments about that one. All right, when we go and we do logarithms, it's undefined for a log of a negative number. It's undefined. This is undefined. Can't have a negative in this spot. Can't log a negative. Can't log a negative. That's going to be important in one of our homework questions, but I don't have one that's in the assignment that is exactly like the homework. So as soon as I give you the homework, we'll go over that one together. Huh? So 3 points. Sort of. I mean, I'm not going to give you the answer, but I'll help you get started. All right, the last section, I changed the middle one. So if you are working ahead, I changed B in the bottom. Don't do B yet. All right, so we are solving for x. When it is in log form, it's not always easy to solve for x. A lot of times it's easier to change it to exponential form. So I'm going to change this to exponential form. 3 to the 5th is equal to x minus 3. So what's 3 to the 5th? 243 is equal to x minus 3, so x is 246. If I plug that back in, and I do log base 3 of 243, or 246 minus 3, 243, that's doable. It's going to equal 5, yeah. So this is the one I changed. This one. The only thing I changed is I made it 3 halves instead of 3. Okay, so if you want to make that 3 halves. So it's not always easy to do solving with a log in it. It might be easier to change it to exponential form. Well, let's change it to exponential form. What's my base? X to the 3 halves, 343. So how do you cancel out an exponent of 3 halves? Because I just need to be x. How? So how do you solve for x? What do you think, Jason? We need to make the exponent 1. We need to make the exponent 1.
I could square root it.
So instead of like, except for opposite of what he said, totally opposite of what he said, totally. Okay. So this is square root and cube. If we cube root and square, that undoes this. So what we're really going to do is we're going to raise this whole side to the 2/3 power. And if we do it to that side, we're going to do the other side. And when I raise power to power, I multiply my fractions. I multiply my exponents. And so that's gonna give me x to the first over there. And then on this side, are we gonna do root first or power first? Should we do cube root first or should we do squared first?
Cube root.
So we'll do cube root first, then square that answer. What's the cube root of 343?
7.
Squared.
49.
That's a 49. So I changed this question because I want to make sure we knew how to do, to cancel out that exponent. All right, then the last one's pretty easy. 3 to what exponent is 1/9? -2. Oops. Okay. When I give you the worksheet, go to the last question, because that's the one that I didn't have an example in notes, and I want to make sure we know how to do it. So go to the last question. Get the worksheet, go to the last question. Yep.
Oh, no.
So go to the last question. I'd rather you have the opportunity to do the hardest one in class rather than trying it on your own. What base is the last question?
10.
It is not base x. Not base x. It's 10. So they didn't write the base. You have to know that it's 10. So that x multiplied by x plus 15 is that whole big number spot. Yes, you do. All right, if you're gonna factor it, you have to set it equal to 0. If you're solving by factoring, it has to say equal to 0. Well, how do you say that's equal to 0? Right, you're doing the set each factor equal to 0. You're doing that part. No, you can't do it. Unless it says equal to 0, you can't do it. You can't set it equal to 100. Okay? So what you have to do is you have to subtract that 100, but then it's not factored in. So you have to distribute. Okay, so the problem is when we plug these answers back in, one of them's not going to work. And it has to do with this. So throw one of those out, cross one of those answers out, figure out which one it is. Yep, so you're going to factor it or quadratic formula. If you're factoring it, you Alright, so because of our list, we can't have this. And plug these numbers back in, one of them is not going to work. Oh yeah, you can. There was almost factored right. One of them's going to be good. You'll see. Okay, so our notes. What can we not do? Why,
Negative.
so which one of those?
5.
Cross off Okay, so with your answers, did you get x equals 4 for that? This is not totally right. like, distribute? If you can, or factor. So with our notes today, we talked about why this is not helpful. So one of these answers, if you plug it in, you're gonna have log to negative. So one of those usually is an extra solution that you need to toss up. If you plug that in, you're gonna have log to negative. Right? Hey, you guys, I lied. Both of those work. I lied. Because if you plug in the negative into both x's, they multiply together and give you a positive, so it's not a negative. Gosh, that's embarrassing. Anyway. And I go, what did I think? Yeah, well, because I was just thinking about the first x. I wasn't thinking it through. That's the mistake I'm making today. Casey, did you hear what I was saying about the last one?
Yeah.
Who else had that answer already? So both answers work for the last one. I apologize if I tell you for one out. I was wrong. Now that I think about it. You can't do log of a negative, but what were you That's what I was saying. I was thinking one different, but they were a little. So they both work. Sorry about that. But you still want to go over that one because we're back. I would leave it because we're writing it in exponential form, so I would like to leave it. This is not really very important. This is just making sure you know how to switch it so that when you get to the harder stuff, you know how to switch already. Yeah. We'll do some work over that. And then you go for 3/4. Yeah. I'm pretty sure that's right.
Are my answers anyway?
Yep, that's right.